My name is Thomas Arts and I work in the Eternity project mostly on testing the Eternity blockchain. That was a long time ago when I started coding, on the old Apple II, if people remember. So I basically have an academic career and have always been coding from when I was very small. And then I moved to Ericsson after my PhD, started to learn Erlang, which I really enjoyed. Helped the development of the Erlang community and the Erlang programming language. And then I moved to Chalmers, became a professor there and started my own company in testing technology. And so this is how I ended up then in Eternity later on. It's a functional language and one with concurrency. And the combination of how this is solved is very neat and elegant in Erlang. And that makes Erlang really a nice language for quickly getting concurrency in place. Which I really like. It makes 100% sense to make any blockchain in a functional programming language. And we also using mostly the functional part of Erlang, but we also have, of course, concurrency running around. But the concurrency and distribution in Erlang are not key to this blockchain, but they're very useful. Friends asked me, why don't you join this? That's how I got into Eternity. Yes. I've always been involved in the testing technology used in Eternity, but in the beginning I worked on synchronization of different nodes over the network. But I've basically touched any area in the blockchain because everything needs thorough testing, so I've done that all. So we're different from normal traditional testing. What we do in the blockchain community, in Eternity, is you don't write test cases. That's dull and for far too manually demanding. So we generate test cases automatically from a mathematical model that we built on how the test should, or how the system should work. So you write down in a kind of mathematical way, the system should do this, and then millions of test cases are automatically generated for it and executed. So we can find all kind of weird bugs very quickly. Mm-hmm. So one of the things in what you can ask yourself is, what makes testing difficult, right, for this kind of software projects? And one thing you see in Ethereum or in Bitcoin, they have one or two kind of transactions in the beginning. Probably don't know exactly how many Ethereum has at the moment, but you could, for example, in Bitcoin spend something, and that's a spend transaction. In Ethereum, you have your contract transaction, and you can call a function in a contract. But in Ethereum, you have far more different kinds of transactions. You can do spend, but you can also create an oracle, you can create names, you can spend to a name. So all these things are starting to interact. You can spend to an oracle, you can probably call an oracle from a contract, or you do a contract in the state channel, which calls an oracle. Now this very quickly gives you an enormous amount of test cases to write if you want to just touch that service. And that's why this is practically impossible. Right? You cannot write that many test cases just by hand. So therefore we generate them automatically. Where everything is first class and where you therefore also have a transaction for doing that first class, and they can interact in very many ways with each other. And therefore it's important that you test all the border cases. And one of the things that you then find is, for example, what happens if you spend to yourself? Now, probably a programmer has made that clear that, okay, if you spend to yourself, we first subtract and then we add it again. But not that you subtract and forget about subtraction and then you add it, because then you will be richer in the end, right? Now that kind of mistakes are makeable in some sense, and the programmer will probably have done that. But then you start to name an account and you give your own account a name and you spend to that named account. Is it still checked that you don't spend to yourself and that you get extra money if you do so? That kind of things are testable and have to be tested very carefully. At the moment we develop Fate. Fate is a new virtual machine for the blockchain, and Fate has to be very carefully tested, of course. So we do that as well with this technology, where we generate test cases just to have a broader scope of what we can test. Fate is a virtual machine, and a virtual machine is a machinery where you can execute your contracts. So at the moment, in Minerva, the contracts are compiled to the AEVM, as it is called, the Eternity Virtual Machine, which is based on the same kind of virtual machine technology as Ethereum. But now we come with a new virtual machine, which you then have to compile to. So there's a compiler that compiles Sophia contracts to Fate, that has to work well. And then there's the Fate machinery, which has to run everything, oracles, contracts, well, always contracts, but oracles in contracts or state channels or whatever. And that is a lot of work to test all the corner cases off. And the whole idea is that we, with this new virtual machine, will be faster and take less gas per operation, which seems to be working quite well actually. So I see a lot of systems having the same kind of need of thorough testing, and we lift this technology and we use the technology in different domains as well. But you learn always from a certain domain what you can improve in the test case generation engines for other domains. So that is, in my field, that's where I get excited about. I also get excited about the fact that we can run all of this in Erlang, and that it's so neat and smooth, and we can develop the whole thing so quickly with so few people. That's also very nice to see that actually works with functional languages to get that mileage out of your development team. So that's the kind of things I really like. And then specifically blockchain, I don't know yet. I think we have an extremely nice infrastructure for running a blockchain, so it's a super nice blockchain, but you really have to wait and see what applications are going to be run on that blockchain. And there I just simply don't know enough about what people are developing at the moment to see what is the coolest gadget. I think one of the fascinating things about blockchain, which I had not seen in other domains, is indeed the fact that you collaborate with parties that you cannot trust, in principle. So I've worked in the telecom industry, but there you build the telecom switch yourself, and you have open protocols, and you know what the others should say, and if they don't say exactly what you want, then you don't talk to them anymore, and that's fine. In the automotive industry I've worked, and there, and of course, your boxes, they all have to collaborate, but you trust everyone making such a box because they better conform to the standard. But here you have people that can try to sneak things into your standard and try to communicate with you, and that is fascinating. So security and other things are different for blockchain. So last week I think I published a paper on, well, I submitted the paper and will be published soon, on testing a specific part, a security part of the blockchain. How do you get more trust in your own security, but also how can you trust if other people write that security part, how can you see that it actually does what it should do and not a little bit more? So that's the kind of things which I like to work